path algorithm. Shortest path algorithms, right? So let's yeah, this is one of the popular algorithms you will be learning in next semester, but I would like to just touch upon it from the interview perspective, where you can go more deep into it. But usually interviewers don't ask direct questions unless you mention the name of this algorithm. But common interview questions would be like this. I think you might have already seen this. This is one such interview question. So there are n cities, and you need to assume that these are costs or maybe distances based on priority. Say like if it is cost, you need to find a route from 1 to 3, whichever is shortest. So if you take a direct flight from 1 to 3, it will be $600. But if you take 1 to 2, 2 to 3, 2 flights, then it will be half. So that is what Dijkstra's algorithm is all about. So you need to find a source to one source to all destinations and optimize the cost. So that's what it is. So you have only one source always, but multiple destinations. But you can change the input and repeat this algorithm to find wherever you want to go. So example is like this. If you take A as the source node, from A to initially A to A is zero distance, zero cost. But if you need to do for other nodes, initialize with usually some books mention it as infinite, some mention it as max value, because in the computers, you can represent infinite. So in the program, we say max range. Suppose if you define it as integer, it will be 2 power integer size, say like 2 bytes if it is in C++. So 2 power 16 minus 1. Okay, so that's something we need to define here. And then start comparing that value with the direct, say like A to B, 1. 1 is less than max value. So mention like this, B is 1. So it's initial comparison purpose. We mention some max value, but ideally later you need to compare all possible paths. So if I need to go to A to B is 1, A to D is 3, again D to B you can go. But what is the challenge? It's more than 1. A to C is 1, C to D, D to B, but it is 3. So the cost is 1, and that is the shortest path. Take only A to B, flight A to flight B. Don't take anything middle. So that's what this algorithm states. So is it nothing but application of breadth first search? Because find all connected vertices and then calculate the cost to each of these, and then find their relevant connected vertices. And if destination is there, and then do the comparison. So it is similar to application of breadth first search. If you go next step, A to C, how do you do? You can do direct 1, or A to B to D to C, or A to D to C. This is again a breadth first search from A to all possible nodes, which will end at C. Out of all those costs, we have finalized direct 1 is better. Now D. So A to D, this is interesting, right? A to D is 3. But A to C to D is 2. So this path is relevant and shortest compared to this. So Dijkstra's algorithm could either pick this or this one also same, A to B to D. So you can take either this flight, B or C, but not direct to D to save cost, $1. But there is no rule, but in your office, say like, if you, in the real world, how would you take prioritization? One is the cost. Second is time, right? Time as well. Suppose if you take A to C, it takes you 1 hour, but this one takes you 45 minutes. You would pick this one, A to B to D rather than A to C to D. If each one takes, total time also should be taken into consideration. And then, compare time, money, and then your priority. But to make things simple, we have just taken only the cost. It can be either time or distance or dollar amount. But in the interview, you can ask for that and then create algorithm accordingly. So same for E as well. 3 is the shortest if you go this route. There is the other route. There is no direct route to E. Other routes might be costly, but A to C to E is the shortest. So it looks simple, but how would you make computer to be educated like that? So from A, you have all the shortest paths and the costs are available. It is nothing but from Vancouver to Toronto, Vancouver to Calgary, Alberta, Seattle, or New York. These are all the flights, the source to destinations. So this is how you can apply this in the real world. But usually you don't need all the paths at a time. What you need is one source to one destination. You don't need for all the other places. In that case, you just need to put a if-else filters or switch to identify only one source to destination. But Dijkstra's initial idea was this. From here onwards, Google Maps or airplane, shortest route, or Amazon supply chain network, they're all modifying this algorithm. And there are 2 more similar algorithms available. One is Belmont-Ford, and second is A-star shortest path algorithms. But more or less all are similar, not too much difference. But Dijkstras has its own limitations. We can go and look into these. These are the limitations. Mainly, it is good only for positive, but most of the cases, our real world applications are having positive weights, means airplane cost or distance, they're all positive, but it doesn't handle negative things. Similarly, since we are calculating from A to everything, if the graph size is big, if you need to do it for all cities in Canada or US, it takes a lot of time. I'll show you in next video while discussing about the interview problem. So it is slow in the performance wise. So single source to every other, but it's not the ideal option if you need to do only a set of pairs. It means if you need, say Google, same as Google Map doesn't want from one place to other. Suppose if your house doesn't have a bus stop or metro station, Google provides you all possible paths where the source can be different. It will ask you to walk to metro or walk to a bus stop, 1 or 2 bus stops, and provides you shortest paths. It means it's not always sticking to source A. It can provide you A to B or B to X or C to Y like that, and asks you to walk further. So such scenarios are hard with Dijkstra's algorithm. These are important things to remember, and this could be asked in the interview. If you give any answer, interviewer will ask you, can I do like that? then you should tell these points. No, with this algorithm, these are the limitations. So we should use either Bellman-Ford or A star, or maybe just a simple priority queue with breadth first search. A simple algorithm should work for small, values. But if the size is big, then you need to find different, these standard algorithms. However, it is a good practice for learning. But just so I have given the code, you can play with it. But in the next video, we will anyway go through the core logic. But this one, just I would like to give you the input and output. The input is like this. Sources are represented with integers 0 to 7. And then these are the connectivity edges, destinations, and these are costs. Okay, cost to travel 0 to 1, 0 to 7, like that. Yeah, paths. So how Dijkstras work? It does breadth first search, maintains a queue for breadth first search means always needs a queue to store those nodes, whether it is already visited or not, and then repeatedly compare through a nested for loop. That's what it is doing. It takes you a while. I would like you to copy this code, play with different inputs, try to understand line by line. But my goal is that we have covered most of the code except this part. This is something you need to do with, on paper, pen and paper. Okay, it takes you around 1 to 2 hours to understand, but this is the core part, and it must be presented in the interview. Okay, but remaining things are already known to you, like maintaining a queue. It doesn't matter whether you use a vector or what I say, or you can use even priority queue. Different programmers use different things. Safe thing is if you are writing in C++, start with vector. It doesn't matter. And there is one utility. I would let you to play with that. It gives you the comparison of this one. If I want to do from A to D, that utility will do the comparison. A to B to D sum versus this one, and provides you the minimum distance. That's what it is doing.
So it's a separate function?
Min distance function.
Okay.
It provides you shortest distance. And once you get the distance, store that, and then mark that visited is a queue. It is a vector, but internally it is a queue of all the vertices. And then from each vertices to other, you need to mark whether the shortest path is already identified or not. So this is interesting, but this is the job defining algorithm. But next video, I would stop here. Let's see the output. This is the output. 0 to 0 means A to A 0, A to B 4, A to C 12, like that. You can also write one more print statement to print the edges. How would I reach A to B? Is it a direct A to B, or A to C to B, or A to D to B?
The path.
Yeah, the path. So that is something you see. Due to the timing of the interviewer would check how would you print, but he doesn't want you to write hundreds of lines of code, because the more you improve, it takes you a lot. But at least this part is definitely needed, this function, until here. This is definitely needed to get the job. But they don't ask you direct Dijkstras algorithm. I'll stop here and take you towards some popular interview questions in a second. Where are we? Do you have any questions before we stop?
No.
Okay.